In the previous lesson, we noticed that after requesting a purchase, the state machine was not able to transition into the items granted state. Instead, it stays in the accepted state. Let's investigate what happened there and see if there's something we can do about it. Let's go into first into our Get Items tab for inventory to see if, in effect, the items were not granted to the user. So I'll hit Send. And interestingly, the user does have the antidote granted to him. So the granting operation succeeded. But even then, we are still in the accepted state, which is not correct. So let's go back into VS Code. And I'm going to stop this for a moment. I'll close this. And let's try to understand what happened here. So we know that when the items granted event comes back for inventory, we should be switching into the items granted event, but this never happened. Why is this? Well, this is something you could run into depending on kind of the speed of each of your microservices, because this is kind of a timing condition. What happens here is that we send a message right here, right, into inventory, grant items. But then before we get a chance to transition into accepted, which is an operation that has to be persisted into the MongoDB database, inventory already did the granting operation and already sent back a message. So before we got into accepted, down here, we were already trying to receive the inventory items granted event. However, since we were not yet in the accepted state, because it has not been persisted into the database, this transitioning, none of these lines executed, right? We are not in the right state, none of these lines execute. And then, eventually, this operation continues, and we actually transition into accepted state. You see? So it's kind of a timing situation. We do the send, and then before do accepted, we receive the event. We cannot handle the event because we're not in the right state, and then we actually switch to the right state, to the next state, which is accepted. And by the way, this may or may not happen to you depending on if this is the first time that you start the trading microservice or this is the second time or third time, right? After a while, trading may actually be faster and actually do the persistence before sending the message. But to make sure that we get a consistent behavior here, what we can do is use what we call the mass transit in-memory outbox, which will ensure that no messages are sent from this pipeline here, this set of events, what we call the pipeline. No message should be sent until we have transitioned into the accepted state in this case. And so to configure the memory outbox, we'll go back into our startup class here. And here in add mass transit, in the add mass transit private method, we're going to head down into the add Saga state machine section. And in this parenthesis, we're going to provide now a Saga configurator, which expects a lambda, so that we can configure the Saga, and we can say here Saga configurator that use in-memory outbox. Okay, and with that, like I said, no message will be sent from the Saga, from one of the Saga pipelines until we have transitioned into the state in the database. So let's test this out. I'm going to do F5. And then I'll head into Postman, back into our Purchase tab, the Post tab, and then I'll do the operation again. I'm going to try to purchase 5 more antidotes. So I'll hit Send. Okay, we got our correlation ID, which I'm going to copy. And then let's head into the Get tab to see the status of this purchase. Control V that, and then I'll hit Send. And as you can see, now the state is correct. We have switched to the items granted state. And if we head into the inventory Get Items tab, let's confirm that if we do send here, we do have now 10 antidotes. So this succeeded. So make sure you always use the in-memory outbox when you're creating these Saga state machines with mass transit to make sure you get a consistent behavior for the pipelines in terms of always making sure that the state is saved first in state machine and then the messages go out. In the next lesson, we will update the state machine to also send a command to the identity microservice to debit yield from the user. Let's add the final step to our state machine, where it reaches out to the identity microservice to debit yield from the user and complete the purchase. So here we are back in the trading code base, and the first thing I'm going to do is to add the NuGet package for the contracts from the identity microservice. So I'll do Ctrl J to open my terminal. I'll switch to src, play the trading.service, and then I'll do .NET add package, play that identity.contracts. And with that in place, I'll close terminal, and we can go into state machines, purchase state machine, collapse this. And here I'm going to go down into the configure accepted method. And here we're going to send that message into the identity microservice. So just between then here and the transition into items granted, I'm going to open a section here, and I'm going to say that send, and this is going to receive our context. And then we're going to pass in the actual message to send. So we're going to say new debit yield, open parentheses, and then let me do control dot here to use play.identity.contracts. And then I'll send this to the next line, and let's pass in the parameters. So the first one is going to be the user ID. So context.instance.user ID. Next comes the amount of yield, so that's context.instance.purchase total.value. And finally the correlation ID. So context.instance.correlation ID. All right, so that is going to go ahead and send the message at the right time. Now, after identity microservice has done the job of debiting the yield from the user, it is going to send back a yield debited event, right? So how do we configure that event? Just like we did with our previous events, we'll have to go up into our declaration of events right here, and I'm going to declare one more event. It's going to be public event yield debited, and then let's add the getter. Then we go down into our configure events method, and we say event, and that's going to point to yield debited. Okay, so now the state machine knows about this event, but then what are we going to do when that event arrives? So for that, we're going to open up another private method, just like we did with configure accepted. Let's do it down here after configure accepted, and we're going to call it private void configure items granted, because this is what we want to do when we have just switched it into the items granted items granted state right here. So I'm going to go down here to write our configure items granted method. And what we want to say is that during the items granted state, then we'll say comma, and then I'll close this like that. When the yield debited event arrives, then we receive the context, and then we open a lambda expression. We're going to say, just as before, we'll say just context that instance that last updated equals datetime offset that UTC now. And finally, after that, we'll just say transition to, and that's going to be our final state, which is completed. And then let's invoke this method from our constructor. So let's go back to the constructor, and let's add configure items granted. Okay, So once again, going back to configure accepted, just after we receive the event for inventory items granted, we capture the last updated, we send the debit GIL event to identity microservice, and we transition to items granted. Identity will do the job and then eventually sends back a GIL debited event. So during the items granted state, we go ahead and when we receive the GIL debited event, we will go ahead and capture the last updated once again, and then finally transition into the completed state, which is our last state. And then, just like we did with our previous event, we also need to set the queue where we're going to send this, let's go up, this debit GIL command, because this is a command style message that's going to land into a very specific queue for the other service to act on it. So Ctrl-Shift-E, let's go into app settings.json, and down here, just where we have the grant items queue address setting, we're going to add one more setting. Let me do comma, and this is going to be our debit GIL queue address, and this is going to be queue identity debit GIL. And if you're wondering where did this identity debit GIL queue name came from, you can head back into your RabbitMQ portal at localhost 15672, and then we're going to do guest, hit enter, and then you can go into queues, and in queues you're going to find, among all these queues, our identity debit GIL queue, which is the one that got created by the identity microservice to receive debit GIL commands. So that's where we need to send our commands. And let's minimize this. And so let's now create a property in our settings class for debit GIL queue address. So just copy this, Ctrl-C. I'll go into settings, queue settings, and then let's add a property, string debit GIL queue address, and then let's make this an init type of property. And with that, let's head back into startup.cs. I'll collapse this. We're just almost by the end of this file. We're going to add a new endpoint mapping, which is going to be endpoint convention.map, and here it comes, debit GIL. I'll do control dot here to use play.identity.contracts, and then I'll do new URI queue settings dot debit GIL queue address. And with that, we're ready to try out a new purchase that's now going to actually go ahead and debit GIL from the user. So to do that, let's first make sure all of our microservices are up and running, at least inventory, identity, and trading. So I'm going to go into inventory, and I'm going to do .NET run in this terminal, and then I'll head into identity right here. I'll also do .NET run, and finally I'll head back into trading, and in this case I'll just do F5. Okay, and with that in place, I'm going to go back into Postman, and just so that we can make sure that the GIL is actually debited from the user, let's query the existing GIL amount for the users that we're using so far. So that user is player 1, and the ID is right here. If you don't have it available there, you can always come back into your get users REST API in the identity service Postman collection. And in fact, let's just do that. Let's manage our tokens. These tokens are expired right now, so I'm going to delete all of them. And I'm going to go down into get new access token. I'll go as an admin, play.com. Okay, and this is going to be our new admin token, use token. And then I'll just hit send. And here we have all of our users, of which we're interested in player 1. So here is player 1. Right now it does have 200 GIL, as you can see. So now let's go back into our post API for the purchase. And then let's go into authorization and let's get a new access token for player one. It's going to be player1@play.com. All right, proceed. Player one, use token. And then going back to body, we're going to say that we want to purchase 5 more antidotes, right? Because that's the item ID for the antidotes. And then I'll just hit send. And now that we have a new correlation ID, let me copy that. And then let's head back into our tab for querying the status of the purchase. So I'm replacing the correlation ID there with the new correlation ID. I'll select the proper access token for player one and I'll hit send. And so as expected, the state has switched to completed, which means that the entire transaction has completed. And let's confirm once again how much yield this user has. So I'll go back to our get users API. I'll hit send. And as you can see, our user now has only 160 yield, which is a result of the debiting those 5 antidotes that we just purchased. So the transaction has actually completed successfully. And with that, you have a fully working state machine. It is doing everything that's expected to do to purchase the item. But as usual, there could be some issues during the execution of this state machine. So in the next model, we will refine our state machine to be more resilient to the different kinds of errors that could occur during its lifetime. In this model, you will learn how to implement compensation in an orchestrated saga and how to introduce idempotency to your microservices to prevent data inconsistencies. By the end of this model, you will have a solid understanding of the following: how to use compensating transactions in a saga state machine, what is idempotency and why it is so important, how to add idempotency to a REST API, how to update a mass transit state machine to handle duplicated events, and how to create idempotent consumers. Let's get started. We previously talked about how compensating transactions in sagas helps us roll back operations that could not be completed across multiple microservices. Let's see where in our current purchase saga we might need to introduce compensation. So here we are in Postman, and I have already started all the inventory, identity, and trading microservices. And so we're going to perform another purchase. But before doing that, let's make sure we know how much items and yield this user has. So if you go to this tab here, this is the one from the inventory Postman collection where we can query how much items for a specific user, which in this case is player one. So I'm going to go ahead and hit send to get those items. So we know we have, he has 1 potion and 15 antidotes. And then if we head back into the get users tab from the identity service Postman collection, I'm going to also go ahead and hit send. And then down here, we can see that this user has still 160 yield available. So, and then let's remember, if you go back to get items from the catalog microservice, we know that our antidote costs 7 yield. So let's see now what happens if I go into post to do a purchase, not for 5 items, 5 antidotes, but in this case, let's see 40 antidotes, which should be actually more than what this user can pay for. It's just too much. So let's go ahead and hit send. And now let's copy the correlation ID and let's head back into the get tab to get the status of this purchase. I'm going to paste there the correlation ID and then I'll hit send. And so as you can see, the transaction did not complete. It is stuck in the items granted state. And if we go back into the get items tab to see how many antidotes this user has now, I'll hit send. And we can see that in fact, 40 more antidotes were granted to this user. Now he has 55. But if we go back into get users to see how much yield he has, he had 160, we hit send, he still has 160. So the items were granted, but the yield was not debited. And why did that happen? Well, if we go back into the identity microservice, we can see that if we scroll up a bit, we can see a fail here, an error, and it clearly says insufficient funds exception, not enough yield to debit 320 from user something something, right? So identity, as expected, was not able to debit the yield, which is good that it was not able to do it. However, our state machine was not notified of this, right? And it did not move forward into transitioning into a more meaningful state. But of course, the main issue is that we have an inconsistency. Items were granted, yield was not debited. So how do we handle this? So let's head back into trading, and I'm going to do Ctrl+C here. Now I'll close this, and let me open Ctrl+Shift+E, my Explorer, to go into our purchase state machine. So it turns to be that mass transit can actually let us know when one of the events or one of the operations in the other microservices, external microservices, fails, right? And it is able to do it via what we call fault type of events. So mass transit will emit these faults whenever such events happen. So what we want to do here is to capture those faults and do whichever operations we need to do to compensate the failed transaction if needed. To do that, let's go all the way up here into our section for the events, and let's declare two more events. So this is going to be public event. It's going to be a fault event. So it's a fault of grant items. And let's call this one grant items faulted with a getter. And let me go back to fault and do a control dot to use mass transit. And then let's add another one. Public event fault of debit yield. Debit yield faulted. Again with a getter. Okay, so those are the two events that are going to notify us whenever one of our other microservices faults when trying to do their operation. Now we have to go down and configure these events as we did with the other ones. So we're going to say in the configure events method, event, and the Lambda expression is going to read like this, grant items faulted. But in this case, we will have to specify very clearly what is going to be the correlation ID for these fault type events, because mass transit will not be able to infer it automatically since it's a fault type event. So for that to work, we'll have to provide another expression here, which is going to say correlate by ID, and then we provide another expression which is going to be context, and then we'll say context.message that correlation ID. And let me send this to the next line so you can see better here. Okay, so this is how you can correlate one of the faulted events. And just like we did this, let's also correlate. I'll just copy paste there. Let's do the correlation for debit yield faulted. Correlate by ID, context.message correlation ID. And we do message twice here, basically because the first message is the fault and the second message is the actual debit yield message that was sent originally. Okay, so then what do we do when one of these faulting operations happen? So let's see. Let's go down into configure accepted and let's reason a bit about this one. So if we were in the accepted state and we did not get an inventory items granted event, but instead we got a grant items faulted event, what should we do? Well, since this is the very first operation, I mean, granting items is the very first operation in our transaction, there's not really much to do. The only thing that we want to do is perhaps record the error message and then be done with it, right? There's nothing really to compensate. So the way that we declare this compensating event here is by opening up another section at the end here, just after transition 2, I'm going to open up another section by doing a comma right here. And then I'll just do when grant items faulted, we will say that then we receive the context, land expression, and here we're going to say context.instance.error message equals context.data that exceptions, and these exceptions is an array that will include whatever exceptions came back from the other side, which in this case we're interested in the first index, just index 0, and then that message. So that will include the exception that we're interested in. And lastly, we will just say context.instance.last updated equals datetime offset.utc now. And of course, you want to be very careful with the assignment of the parentheses and curly braces in here, right? So notice that we're doing this really at the same level of the first when that we have up there. We're doing another when after a comma for grant items faulted. If that happens, then we just do this. And like I said, there's nothing much more to do, nothing to compensate in that case. But what we should do is to transition, in this case, into the faulted state. So after that, we will just say dot transition to faulted. So that will put us in the correct state. Now, the more interesting case is going to be in the next section in configure items granted. Because if we were in the items granted state and we were not able to debit yield and we got a debit yield faulted event, we do need to do a compensation. And to do that, we need to send a subtract items message back into inventory. So how do we do that? So once again, let me scroll down. I'll do comma here, and I'll go back to the level of the when, and I'll say when debit yield faulted, we will do send, and here's the context, lambda expression, new subtract items. That one we have to pass the parameters like context.instance.user_id, context.instance.item_id, and context.instance.quantity, and finally context.instance.correlation_id. Okay, so that way we are instructing inventory that it's time to compensate the previous transaction by subtracting the items that were granted to the user. And after we do that, we will do then, we say context, and in this section we're going to record what happened. And this is actually going to be very similar to what we just did for the other case. So I'm going to copy these two lines from the previous method down here into the context there. We just capture the error message and the last updated. And finally, we will do dot transition to faulted. Okay, so if we were in the items granted state and we got a debit yield faulted event, then we send a subtract items command into inventory so that it compensates the transaction, the previous transaction, and then we record the error message, the time, and then we switch to faulted state. And then one last thing that we want to do here is to say something about what happens if any other message or event tries to arrive into the state machine while we are in the faulted state, right? Because there could be more messages coming in for this same state machine instance. I want to handle those in some way. To prevent the state machine to fall into an unexpected state or to throw any unexpected errors, what we're going to do is to just add one more method, maybe at the very end, right here. We're going to call private void configure faulted. And so on this one, we will just say, during the faulted state, let's close that. During faulted, we will ignore purchase requested. We will ignore inventory items granted, and we will ignore yield debited. Okay, so this means that if we already are in a faulted state, let's not pay attention to any new purchase requested, inventory items granted, or yield debited events. Now let's make sure we call this method from the constructor. So let's go all the way up to our constructor, purchase state machine, and let's add configure faulted. And then let's do the same configuration we did for the previous queues that we're using so far. So I'll do Ctrl-Shift-E. I'll go into AppSize.json. And here I'm going to add yet another queue, which in this case is going to be subtract items queue address. And then that's going to be queue inventory subtract items. We'll do the same thing in settings, queue settings. Let's add our subtract items queue address as an init type property. And finally, let's go back into startup, collapse this, and at the very end where we're declaring the endpoint conventions, let's add one more convention, which is going to be endpoint convention.map subtract items new URI queue settings dot subtract items queue address. Okay, and with that in place, we should be able to try out our operations again and see things getting compensated properly. So I'll just do F5 this time in our trading microservice. And then I'll head into Postman. And once again, let's verify what we have right now. So the user has 160 yield right now. And also he has 55 antidotes assigned at this point. Then I'll go to post. And I'll try the purchase once again. So I'll just hit send. And now we got a new correlation ID, which I'm going to copy now. Ctrl-C. And I'm going to go into the get tab to get the status of this purchase. I'll delete the correlation ID and I'll paste our new one. And let's see what happens this time. I'll hit send. And now we see the expected state. The state of this purchase is faulted. And the reason is right here. Not enough yield to debit 320 from the user. That's right there. So this is looking much better. But then let's see what happened with the actual transactions in the different microservices. So if we go down into get items, we had the user had 55, and then I'll hit send again. Let's see what we got now. And indeed, he still have those 55 antidotes. So no new items have been granted, or at least it looks like no new items got granted. It's just that we subtracted the items when the operation failed. And if we go to get users, and we see for player one, we had 160, hit send, and he still has 160. So basically, the transaction got rolled back, right? Because the user didn't have enough yield, and things are looking good across all the microservices. So the transaction has been compensated properly. However, compensation is not the only issue we need to deal with in our purchase saga. In the next lesson, we will talk about idempotency and why it is so important in the context of microservices. In this lesson, you will learn what idempotency is and how to add idempotency to your REST API operations to prevent unintended consequences. To understand what is idempotency and why it is so important, let's first explore one unexpected scenario in our purchase process. So, just as before, our client sends a request to purchase 5 potions to the trading microservice. Trading publishes the purchase requested event and immediately tries to reply when an accepted response. However, this time the response never reaches the client. This could happen for many reasons, like if the client or trading loses its network connectivity temporarily, or maybe either the client or trading just crashes in the middle of this request. Let's imagine in this case that the client just lost its network connectivity temporarily. Trading is likely unaware of this, and since the purchase requested event was published, the purchase state machine is triggered and performs its usual steps of calculating the total yield and requesting inventory to grant the items to the user's inventory back. Inventory grants the 5 potions, and the state machine moves to the accepted state. After the client recovers from the network connectivity issue, it's left wondering if trading ever got the purchase request, since it was not able to get a response. A logical thing to do then for the client is to retry the operation to honor the user's request. The client sends the purchase request once again, and trading fires a purchase requested event just as before. This time, the accepted response from trading successfully reaches the client. However, this has now triggered a new purchase process that will ultimately result in the user receiving 5 more potions in his inventory bag. As you can imagine, this is pretty bad. But why did this happen? Well, to start with, the client went ahead and retried the operation without caring at all about the outcome of the original request. On the other side, the trading microservice had no idea that this was a retry of a previous purchase request, since it received no hint about this in the request. Ultimately, trading ends up duplicating the entire purchase. So, what can we do here? It's time to talk about idempotency. What is idempotency? Here for a simple definition I found on the web. Idempotency is the ability to apply the same operation multiple times without changing the result beyond the first try. Some operations are naturally idempotent, like when you send a put request to the catalog items REST API. No matter how many times you send a put request to update the antidote price to a yield, it would always result in antidotes to have a price of exactly a yield. But other operations are not idempotent at all. Like in our previous example, each purchase request will result in a new purchase transaction, each of them granting items to the user's inventory and debiting yield from his wallet. Let's see how we can add idempotency to an operation that is not idempotent by nature, like in our purchase example. Here is a revised version of our purchase example. The client, once again, sent the purchase request to the trading microservice. But this time, it sends one more thing along with it, an idempotency ID. The idempotency ID is a unique value that both the client and trading can use to refer to this specific purchase operation. When trading receives the request, it fires a purchase requested event, including the idempotency ID, so that the purchase state machine can also use it to keep track of the purchase. Just as before, the response never makes it back to the client. But regardless, the purchase state machine starts and eventually asks inventory to grant 5 potions to the user's inventory bag. The state machine has moved to the accepted state. Again, the client recovers from the network issue and wonders if the purchase request was ever accepted. So it decides to perform a retry, but this time it has been keeping track of the idempotency ID and uses it as part of the retry request. Trading gets a request and fires the purchase requested event with the idempotency ID, after which it sends the accepted response back to the client. Now, since trading has also been keeping track of the idempotency ID, it notices that it already has a state machine instance for that purchase and that it is already in the accepted state. So there's no need to start a new purchase and the duplication is avoided. As you can see, a big benefit of using idempotency here is that the client can now safely retry the purchase operation without ever worrying about duplicated transactions. No matter how many times the client retries, as long as it uses the same idempotency ID, the service will be able to easily correlate back to any previous operation and avoid starting a new purchase if the original one is already in progress or completed. In the next lesson, we will update our purchase requests to become idempotent. Let's see what's the effect of not having an idempotent purchase operation in our trading microservice. So what I'm going to do is go into our controllers directory, purchase controller, and I'm going to collapse this. And here in our post async operation, I'm going to introduce an additional delay here just to simulate the case where the operation is taking more time than expected. So I'm going to add a new line, and I'm just going to add a wait, that's that delay. It's going to be time span from seconds 5. Okay, so it's going to take 5 seconds to complete, a little bit more than 5 seconds. So now I'm going to do Ctrl J, and I'm going to do .NET run. So this is going to start the service, and I have already started our other microservices, and I also have our front-end portal up and running. So now we're going to go into Postman. And one change we're going to make in Postman is to modify its settings so that it does not wait indefinitely for an operation to complete. And we can do that by going into the gear icon over here, then click on settings, and then into request timeout in milliseconds right here, where currently it says 0. So by default, Postman just waits indefinitely for the operation to complete. But now we're going to say that it's only going to take at much 3000 milliseconds or 3 seconds, right? So which is more close to what a real client would do. So I'm going to close this. And I'd also like to know how much exactly of GIL and of items our user currently has, so that we can compare what happens after we do the purchase. And to do that more easily this time, I'm going to use our front-end portal. So I'm going to go over here in this tab where I already have the portal up and running. And I logged in as an admin. And I'm going to go into the users menu. And here we can see that our player 1 currently has 160 GIL. And if you go into the inventory bag by clicking the inventory bag here, we can see that he has 1 potion and 55 antidotes. I'll go back to users, and then back in the Postman, I'm going to try our purchase operation, not for 40, but let's just say 3 antidotes this time. So I'm going to hit send. And as you can see, this is just taking too much time, and eventually it results in a timeout, right? It could not complete the operation. Now, we still want to know what was the status of the result of this purchase transaction. So since we don't have the correlation ID here, what we can do is go back into VS Code. And here in the console, what you want to do is look for a line that looks like this. Saga, and then goes all the way down into purchase state. There's a GUID right here, and then it says use play the identity contracts GIL debited. So this line and this GUID right here is the correlation ID that we can use to query for the state. So I'm just going to copy this into Postman, and I'll go into the get tab where we can query the status. I'm going to replace that correlation ID with a new one. And then I'm going to go ahead and hit send. And it does say that the operation completed, right? The status is completed. But then what happened with the items and the GIL? So if we go to the portal, we can see if I just refresh this page, we can see that player 1 now has 136 GIL. And if you go to inventory bag, he has 58 potions. So everything actually completed, right? Even when we got this timeout here. So then the client decides to retry, right? Because he doesn't know what happened. So I'll go ahead and hit send again. And then, of course, again, we get the timeout. And then if you go back to the portal, what we can see now is if we refresh, that the operation happened again. So a new debit, and if you go to the inventory bag, the user now has 61 potions. So that is what the client was not expecting, right? So we should not have a duplicated purchase operation. So what can we do to prevent this situation? Let's go back into our trading microservice, and I'll do Ctrl C and I'll close this. And what we want to do is to provide for some way for our state machine to know that we are dealing with an already ongoing purchase transaction. And we can do that by making sure that we reuse the same correlation ID every time, that we're repeating the same transaction. Right now, we're generating the correlation ID right here, as you can see. So anytime a purchase comes in, a new correlation ID is created, and so that generates a new transaction. State machine believes it's a new transaction. So we have to address that. So in order to do that, I'm going to do Ctrl-Shift-E, and then I'm going to go into DTOs. And here we're going to add one more item into our submit purchase DTO class, which is going to be GUID idempotency ID. Okay, so now the client will have to send over the ID, the idempotency, this unique identifier that we call idempotency ID, that we're going to turn into the correlation ID for the state machine. Let's also make it so that this one is required. Okay, and also nullable, just like our item ID, to make sure that it actually provides a meaningful value. Then we're going to head down into our purchase controller over here, collapse this. And now, instead of generating this correlation ID, we're going to remove that line, and we're going to grab our purchase.idempotency ID from the DTO, that value, of course, because it's nullable. And that's what's going to be used to send over into the state machine, right? So that is in the message, and the message will go into the state machine. So now the state machine should recognize that we are dealing with the same correlation ID if the client sends the same correlation ID, and it should not try to do a purchase again. Then we also need to fix these other pieces here, where it should be purchase.idempotency ID, and the same thing for the last parameter over there. Let me actually send this to a new line to see better. Yep, so like this. And one more thing that we can do is, since we are changing the meaning of the accepted action, the way that we are sending into get status async is by using the idempotency ID, let's totally switch, going back into our get status operation. It's not going to read as correlation ID anymore, but we're going to do idempotency ID instead. So I'm going to hit F2 right here, and I'm going to say idempotency ID. And let's also copy that and put it into our template for the get verb right there. Okay. So with that, let's do Ctrl-J, and I'll do .NET Run once again. And let's head back into Postman. And if we just try the operation as is and try to hit send, what we're going to get, of course, is a validation error because the idempotency ID is now required, which is good. So I'm going to open up another line here. I'm going to add idempotency ID. And then we have to come up with some sort of ID. And I think the easiest way to do that is to just use the GUID function from Postman, which is going to read like this. Good. So Postman is going to generate that correlation ID. And then this is what a real client will actually generate by itself, right? Before sending it down into the microservices. So with that in place, let's hit send. And then, of course, we get a timeout. But if we go back into VS Code, we do have, again, a new correlation ID right here in this line. I'm going to copy that back into Postman, into the Get Status tab. I'm going to replace that correlation ID, hit send, and then, yeah, we can see that the operation did complete. And then if we go to the portal, back into our users tab, we can see that our user now has 88 antidotes, 88 GIL. And then if we go to inventory, he has 64 antidotes, which is expected. But now if we go back, and I'm going to go back to the previous tab, and then we go back to Postman and we go to post. Now the client is going to retry again, but this time is not going to come up with a random GUID. It's going to say, hey, I already know the idempotency ID I sent before, so I'm going to reuse it here. And I'm just going to do Ctrl-V, because this is the one that we just copied to get the status, right? So now the client is retrying with the same idempotency ID, and then it's going to hit send. And of course, it's going to time out again. But again, if we query the state of the state machine over here, hit send, it still says completed. And more importantly, if we go back to the portal, where we currently had 88 GIL for our user, we hit refresh, you can see that our user still has 88 GIL. So nothing changed here. And if you go to the inventory back, it still reads as 64 antidotes. So there was no effect in the state machine. State machine recognized that this purchase was already completed, so there's nothing to do here. Let's now also remove that delay that we had created over here. So I'll just Control C, close this. Let's now remove the delay to see this in a more real situation. Okay, so no delay anymore. .NET run. Back into Postman. Okay, so let's go back into the GUID. So let's send a brand new purchase. Okay, purchase completes. We get an idempotency ID. We can see the status down here. It says completed. Back into the portal, into users. This user now has 64 GIL, and in the inventory bag has 67 potions. Sorry, 67 antidotes. And back to users. And then back in Postman, go back into Post. We'll grab, we already got that idempotency ID in the clipboard. So I'm going to Control V here. I'll hit send. And you see, it just says accepted. Nothing changes in the status, right? Same status. And in the front end, we refresh, and he still has 64 GIL, and the inventory bag still has 67 potions. So that is the way to properly handle idempotency at the point where we call our REST API and in the state machine. However, let's take a closer look also at VS Code quickly in the console. If you scroll up a little bit, you're going to see a failure here. And if you look closely here, we have this exception here that says SAG exception on receipt of play trading service contract purchase requested, not accepted in state completed. And what does that mean? Well, let me close this for a moment. If we go into our state machine, that means that it is receiving our purchase requested messages, but not in the initial state, but in the completed state, right? So when it is already, it has already done this line here, completed, the state machine is completed, but the message is saying, hey, I cannot accept a purchase requested event when I am already completed. So that's why we have this error here, which really doesn't mean anything in terms of the execution of the transaction. The transaction was correct, no duplication, but we should not keep these errors hanging around here. So in the next lesson, we will update our state machine to properly handle the idempotency ID. Let's see how to fix our state machine to properly handle the case where it receives messages that are not in the correct order with respect to the current state. So in the previous lesson, we saw what happens when the state machine receives a purchase requested event, even when the machine is already in the completed state, right? As opposed to be in the initial state. This is something that you have to be careful about in your state machines, because messages can actually land in any order, regardless of the state where the machine is right now, right? This is true both for the initial state, for the accepted state, and all the states that you have in your state machine. So we have to do something about that. Let's handle first that scenario where we receive a purchase requested event when we are incompleted. So what we want to do in that case is to properly add a section to handle things in the completed state. So I'm going to go down into just before configure any, right here. And let's declare a function that we're going to call private void configure completed. Here we're going to say during completed. I'm going to close this. There, during completed. What we're going to say is ignore purchase requested. And by doing that, then if the state machine is already in the completed state and a purchase requested event lands, then the state machine is going to just do nothing and completely skip that message, because it knows that that purchase already completed. And then, since we're doing this, what would be good is to also handle the other cases. Like, let me just copy this to the next line. What happens if we get an inventory items granted event when the state machine is completed? So in that case, ignore inventory items granted. In the same way, if we get an yield debited event when the state machine is completed, we should also ignore that. So this block is going to take care of all these messages out of order when the state machine is already in the completed state. And let's make sure we call this method from the constructor. So let me go back to constructor right here. After configure faulted, we'll say configure completed. Then we should do the same thing for the other states, right? Not just for the completed states. So for instance, if we go into configure accepted, what we're going to say just after the first line and before the first when, we're going to say, hey, if I am already in the accepted state, go ahead and ignore the purchase requested event because I have already moved forward into an accepted state, so I'm not going to process anymore a purchase requested event. And the same way, I'm going to copy this line. If we go down into our configure items granted method here, during items granted, well, again, I'm going to ignore any purchase requested events because I already moved forward into the items granted state. And I'm also going to ignore any other inventory items granted events because I already moved forward. Okay, so that's really what we have to do here. And to test it out, I'm going to do Ctrl J and I'll do .NET Run. And again, my other microservices are all up and running. So I'm going to go back into Postman and into our Post tab. And I'm going to go back and just undo this last line here so that it is just a random GUID for the idempotency ID. And I already got my access token, so I'm going to go ahead and hit send. I got my idempotency ID. And then I'm going to query for the state of the machine in this other tab. And come here, I'll pick my player 1 token, hit send, and yeah, the machine already completed, right? State machine completed. So then I'm going to go back into Post and I'm going to reuse the same GUID, right? For the idempotency ID, which should cause the state machine to do nothing. So I'm going to hit send. Okay, and then we go back into the status, I'll hit send again, and the state machine is still in the completed state. And if you go back into VS Code, you'll notice that there are no more any errors. No more errors happening here. And that is because the state machine is properly skipping any messages that are really out of order. But then our REST API and our state machine are not the only places where we need to deal with idempotency properly. What about our inventory and identity microservices? In the next lesson, we will learn about message duplication and idempotency in the context of message consumers. In this lesson, you will learn about message duplication and how to use idempotent consumers to properly deal with this issue. To understand the issue of message duplication, let's go through the scenario where yield is debited from the user's wallet. As you know, as part of our purchase process, a debit yield command will eventually be sent to the identity microservice via our message broker. Identity will go ahead and debit 5 yield from the user in its local database, resulting in, say, a new total balance of 5 yield for this user. Identity will then try to send a yield debited message back to the broker. But something goes wrong and such message never arrives to the broker, either because Identity or the broker has network connectivity problems or because either of them just crashes in the middle of the operation. Since the broker has not received an acknowledgement of the message it sent, it decides to redeliver it. Therefore, it sends the same message again to Identity. The service treats this as if it was a brand new message and proceeds to debit 5 more yield from the user's wallet, leaving him with a new total balance of 45 yield. And this time, the yield debited event is able to reach the message broker. As you can see, The main issue here is that the service consumes every message as if it was a new message, and each time it is received by the service, it results in more yield debited from the user's wallet. Basically, there is no idempotency in how the consumer processes the message, which results in an incorrect yield balance for the user. What can we do about this? Here's where the idea of having an idempotent consumer comes into place. When any service consumes a message from the message broker, it usually includes a unique identifier, a message ID. This message ID comes as part of the header of the message and will be included anytime the broker redelivers it to any consumer. So this time, when identity receives the message, it first asks the question, have I seen this message before? This likely translates into the service querying its own database, where it would have stored any previously received message IDs. Since this is the first time it receives the message, it can't find it in the database, so it proceeds to debit the file yield from the user, and in this local transaction, it includes the message ID, either as part of the updated user record or document, or perhaps in a separate table or collection where it stores processed messages. Then the service tries to send the yield debited message, but again, such message never reaches the broker. With no acknowledgement from the service, the broker decides to redeliver the message, so it sends it again to identity. But since this is the same message as before, it includes the exact same message ID used the first time. So again, the first thing identity does with this message is confirm if it has seen it already by checking its local database. It successfully finds the message ID and decides that there is no need to process such message again, so it does not perform any database updates. And then it publishes the yield debited event, which this time successfully arrives to the broker. As you can see, when an idempotent consumer processes the same message twice, or any number of times really, it is the same as if it processed it only once. And this brings the expected benefit of not causing any inconsistencies in the service's local transactions, like the modification of the user's yield balance. In the next lesson, we will see how to modify our inventory and identity microservices to become idempotent consumers. Let's explore the message duplication issue firsthand, and then let's use idempotent consumers to properly handle them. So here I am now in the inventory code base, and what we're going to do to understand what happens when you get duplicated messages is to do a quick modification to one of our consumers and introduce an unexpected exception. So I'll go into our consumers directory and grant items consumer. I'll collapse this. And then what we're going to do is to cause an exception to fire just after the inventory items repository gets modified in this if else, and before we publish the message. And so to do that, let's go up here, and at the very start of this class, let's declare a private static int retry count field, which will start at 0. And down here, like I said, just before we publish the message, let's open a line, scroll down, and we're going to do this. If retry count is less than 2, we will do retry count plus plus just to increase by 1. And then we're going to throw a new exception, which is going to say just something like something bad happened, right? Okay, so the effect should be that first time we try to consume the message, our counter starts at 0, and then we perform the database update in this block here. And then if we have not reached 2, we'll go ahead and increase the counter and throw the exception. So we should kind of retry at least a couple of times before successfully publishing the message. And I'm going to put a breakpoint right here in the if else clause, and I'm going to hit F5. And then I'm going to do the same thing for our identity microservice, not with the retry, but I'll just start it with an F5. This is identity. And finally, I'll go into trading, and I'm going to start it. For this one, I'll just do .NET run. And then I'll go into Postman. into our post tab, and I'm going to prepare a new purchase. So I'm going to go back to our GUID, random GUID for the idempotency ID, and then I'll just hit send. So now back in inventory, of course, we are consuming the message, right? So we're consuming the message, and we're going to step over. It does find the item, and then it updates the quantity, updates the item in the database, okay? And then it notices that the retry count is still 0 in this case. So it will go ahead and fire an exception, right? So I'll say continue. And given that we have configured 3 retries in our common library for mass transit and the broker decide to just go ahead and retry this message, right? So here we are back with the same message. And then again, we find the item, but then this very bad thing happens. We already had added those 3 antidotes to our user's inventory pack, which totals 73, but now it happens again. So now quantity is 76. And so if we let it continue, of course, it is going to crash again. I think we can see the exception here. Yeah, you can see something about the exception right here. And then it comes again, right? It comes again. It will do yet another update. Now we have 79 antidotes for this user. And this time the retry count is 2. So we will go ahead and publish the message. Okay, so this finishes. And at this point, the whole operation should have completed. So let's explore our idempotency ID. So I'll just copy the idempotency ID into our get status tab. And I'll hit send. And as you can see, the operation completed. However, our user now has way more antidotes than expected, right? So because we tried 3 times. So that's the issue of message duplication in action. So this should not happen. So what can we do about this? Let's go back into inventory. Here I'm going to stop this and close terminal and collapse that. So of course the issue here is that this consumer is processing the message, every single message, as if it was a brand new message, right? So it has no idea that some of these messages have already been processed. So we have to introduce some way for the consumer to know that a message has already been processed. And the way we're going to do that is by adding a little collection of message IDs into our inventory item record. That way, every time we process a message and we update an inventory item, we will attach one more message ID to that inventory item that we can later check for as we process new messages. So let me do Ctrl-Shift-E to go into our Explorer, and I'm going to go into our Entities directory, and I'm going to go into Inventory Item. So here, what we're going to do is just add one, we're going to use a hash set in this case. So public hash set of type GUID. So the hash set is a collection that allows you to store a collection of keys that cannot repeat at all. And we're going to call this message IDs with a getter and a setter. Okay. And we're going to, by default, initialize it as a new hash set. And then let's do control dot here to use our system.collections.generic namespace. Okay, so anything we store in this collection cannot be repeated, right? So every message will be stored just once. And then notice that we're doing this this way just because our database is a NoSQL database. So, I mean, if it was a relational database, we could have added yet another table, right, or another entity to track these message IDs. But since this is a NoSQL database and we want to do this in an atomic way, the best way to do it is to do it in the same document where we're saving the other data, right? So it's just one transaction. With that in place, let's go back to grant items consumer. Let's collapse this. And what we're going to do is scroll down a bit. And so going back into this if else, right? So in this first section is where we're creating a brand new inventory item. So in this case, just before the creation, what we're going to do is says inventory item that message IDs that add and then we do context dot message ID dot value. Okay, so this message ID here is actually coming from the header of the message, and it's always available as part of any message that you consume via mass transit, right? It's always going to be in this context. And anytime the message is retried, it will have the same message ID available. So you can use that to detect previously processed messages. So in this case, we just add it to our message IDs collection, and then that will get created into the database. Now, a more interesting case is the case of an update. Because here, if we have already seen that message, we should not perform any more updates. So I'm going to open a section here, and we're going to say if inventory item that message IDs that contains context message ID that value, then, well, there's not much to do here other than polish the message, right? What I'm going to do is just copy the last line over here where we publish, and I'm going to paste it right there. And finally, we will do return so that we get out of this method and don't do any more work. But then if we have not seen that message, we will go ahead and do the update. And we also need to grab this other line, line 47. I'll copy that and I'll add it just after we increase the quantity right there. And that's pretty much it. So let's try this again. So I still have my breakpoint in place, and I'm going to hit F5. So I'll go back to Postman and into our Post tab to perform a purchase. And so I'll go ahead and hit Send. Got an idempotency ID. And then in VS Code, of course, we hit the breakpoint. And then let's see, we'll do step over here. Okay, we are in the else branch. This first time we don't have any message IDs. So there's nothing to do here. So we'll just move over. And then we're going to go from 79 into 82 antidotes. But this time we record that message ID, right? So we are adding it to the inventory item message IDs collection. And then we perform the update. And then of course the retry count is still not 2. So we increase it and we're going to fire deception. And so I'll just do F5. And mass transit will make it so that we consume this message once again, right? And so we'll do a step over. We're back into the else branch, but this time we do have the message ID right there, right? So it should contain message 283. We should be the same as this message ID that we're getting here, message 283. And so this time we'll say, okay, we have that message, nothing to do here. Let's just publish the event and then return. So I'll continue, and then nothing else needs to happen here. There's not going to be any more retries. And if you go back into Postman, we have our idempotency ID. Copy that and go to the Get tab. And then I'll just paste it here to query the status of this purchase. Hit Send. And we can see that the purchase has been completed. But we did not further update the quantity of granted items because the retries had no effect at all in our inventory microservice because the consumer is an idempotent consumer now. Okay, and so with that in place, we can now go back into inventory, and I'll just stop this, close that, and we can now remove these retries, right? So I'll just get rid of the retry count. It's out. And then I will remove this because that was just for simulation purposes. And what we should do now is do exactly the same thing that we did for inventory, but for the identity case, right? Which is even probably more important. Make sure we don't debit Jill more than once. So what I'm going to do is I'm actually going to copy a couple of things from here into identity. So starting with our inventory item hash set. So I'm going to copy these message IDs, and I'm going to head into our identity microservice right here, which I'm going to stop, close terminal, Ctrl-Shift-E, and we're going to go into entities, application user, and here's where I'm going to paste our hash set of message IDs. Control dot here to do using system collections generic. And then we want to go into our consumers directory, debit Jill consumer, And here we want to scroll down here. And here is where we want to do the normal check, right? So if user.messageIDs that contains our context.messageID.value, then there's nothing else to do, right? So notice that I'm doing this just after checking that the user actually exists, but before trying to modify the amount of Jill, right? So if that happens, we'll go ahead and publish the message in the very last line. Let me collapse this. The very last line, I'm going to copy that and paste it here, because we can go ahead and publish the message, and then we'll just return. Okay, and if that's not the case, we will just move forward, and just before the update into the user manager, we're going to add a line that says user.messageIDs add context.messageID.value. Okay, and that's all really you have to do in the identity case to make sure that this consumer is idempotent. And one last place where we may want to do the same thing is back in our inventory microservice. Okay, if I go to Ctrl-Shift-E, our subtract items consumer, right? Because this has the same issue. We should not be subtracting items more than once if the message duplicates. And for this one, of course, we're going to copy as much as we can from the grant items consumer. So this branch makes no sense in the case of subtract. Really, the branch that makes sense is this other one here. So I'm going to copy this section, which happens just before modifying the quantity, back into subtract items. Over here, I'm going to just add that section here. So if you already have the message, we will go ahead and publish not the inventory items granted, but the last line that we have in subtract items. We're going to paste that there. Okay, so if you have the message ID, we just publish items subtracted. Otherwise, going back to grant items consumer, let me copy this line where we actually add the message ID back into subtract items. We reduce the quantity, we add the message ID, and then we perform the update. So now all of our consumers are idempotent consumers. And then let's just do one more purchase to verify that everything is going well. And before doing that, let me just remove that breakpoint that we had in grant items consumer. And then I'll just hit F5 in play inventory. And then I'll do the same thing in the identity microservice right here, F5. Our trading microservice is up and running. And so I'll go back to Postman into our Post tab here. And I'll hit send. And we got our idempotency ID here. I'll copy that back into the get status tab. I'll paste that there and I'll hit send. And as you can see, the purchase completed successfully. So everything is going well. In the next module, we will prepare our trading microservice to participate in the new front-end store experience. In this module, you will enable the end-to-end purchase scenario in an updated version of the front-end portal that will make use of a new REST API and real-time updates via SignalR. By the end of this module, you will have a solid understanding of the following: how to use data from multiple microservices to support a client, how to build a REST API to support the front-end store experience, and how to use SignalR to provide real-time updates to clients. Let's get started. In this lesson, you will get an overview of the new store experience enabled in the updated front-end portal and what back-end pieces need to be built to support it. In this module, you will integrate an updated version of the front-end portal with your microservices, specifically the new store section. The list of items presented in this section is similar to the list in the catalog section. But in this case, the user can also tell how much of each item it already has in his inventory bag. There is also a purchase button that the user can now use to purchase a specific item. And also, there is an indicator in the top right that tells the user how much yield is still available in his wallet. We could certainly stand up a brand new microservice to support the store section. But just to keep things simple, we will keep using our existing trading microservice for this. The front end will send a GET request to a new store endpoint to which trading will reply with all the data needed to populate the page. Now, before trading can provide this data, it will need the help of other microservices. Anytime an item is updated in the inventory microservice, inventory will publish a new inventory item updated event. That will notify trading how much of an item a specific user has. Trading will store this in its local inventory items database collection. Also, anytime a user is updated in the identity microservice, especially the amount of yield in his wallet, identity will fire a new user updated event that trading will also consume. And trading will store this data in its local users database collection. In the next few lessons, you will create these new events, the corresponding consumers, and the new store controller. Let's update our inventory microservice to publish a new event that will notify subscribers anytime the inventory bag of a user is updated. So to start with, let's go ahead and define this new event. And that will go into our Play Inventory Contracts project in contracts.cs. And we're going to add this event at the end of this file. So right here, we're going to declare public record inventory item updated. Okay. And this is going to have the user ID, GUID user ID, GUID catalog item ID, and finally, what we're going to call the new total quantity. And we're using this name to make sure we clarify that this is the new, really the total quantity, not how much has been granted or subtracted from the user, but it's a new total quantity in the inventory bag for this user. And with that in place, we're going to go into consumers, and let's go ahead and update our grant items consumer. I'll collapse this now. So here we're going to go down into the consume method, all the way down where we send the publish event. So after publishing this event, we're going to have to publish our other event, which is going to be await context.publish new inventory item updated. And this is going to have inventory item.user ID, inventory item.catalog item ID, and inventory item.quantity. Okay, that will publish the other event. But just to make things a bit more efficient, what we can also do is just publish both events at the same time, as opposed to do it in this sequence serial way. So what we can do here is, instead of invoking the event like this, we're going to just capture the task behind the event that we're calling. So for instance, in this case, we'll say var items granted task equals context.publish for inventory items granted. And the same way, we're going to say var inventory updated task equals context.publish and the inventory item updated. So that way, instead of invoking the task right away via await, we are just capturing both tasks in variables. And then in the next line, we can do this. Await task that when all, and then we pass the different tasks. So items granted task and inventory updated task. So that way we're instructing the runtime to go ahead and invoke both tasks and only get past this when all line when both tasks have completed. And then the consume method finishes. Okay, so now that we are publishing the inventory item updated event anytime we grant items to inventory, we have to make sure we also publish the same event anytime we subtract items from inventory. And that we can do in our subtract items consumer. So let's go ahead and do Ctrl+Shift+E to show the Explorer. Let's go to subtract items consumer and let's collapse this for now. And let's scroll down into our consume method into the section where we check that inventory item is not null. And only in this case, when we are able to find the inventory item, and just after making the update to the repository, that is a moment where we have to say, hey, it is time to publish the inventory item updated event. So let's go ahead and open a new line here, await, and what goes after this word is really the same thing that we just did in grant items consumer. So I'm going to go back into grant items consumer, and I'm going to copy just this section here, copy, and I'm going to paste that over here. And with that, anytime we touch or update the inventory, after subtracting the items, we'll go ahead and publish the corresponding inventory item updated event. And then the last place where we have to also publish this event is in our controller. So let's go ahead and open up again our Explorer, and let's go into controllers, items controller. Let's collapse this, and let's scroll down into our post method. So down here, and here, let's go down here. We're going to have to add a new section just before returning the OK. And here we're going to have to publish via the mass transit publish endpoint. However, we still don't have that publish endpoint defined here. So let's define it first. Let's go up here and let's define private read-only I publish endpoint, publish endpoint. Let's do control dot here and do using mass transit. And now let's do control dot in the variable itself to use add parameters to items controller, repository, there. So with that, as you can see here, if I make this more readable, publish endpoint is being injected into the controller, and then we're capturing it into the publish endpoint variable. And with that in place, we can go down here and just say await publish endpoint dot publish new inventory item updated. Okay, let's do this, and let's do control dot here to import play that inventory dot contracts, and then we can say inventory item that user ID, inventory item that catalog item ID, and inventory item that quantity. So with that, if somebody decides to just grant items directly to a user, we will still get the inventory item updated event for any of our subscribers. And now that we have that, the only thing missing is to publish our updated contracts NuGet package with the new event. So I'll go ahead and do Ctrl J to open my terminal, and then I'll switch into src play that inventory.contracts, and here I'll do .NET Pack, and we need to specify version this time, so it's going to be package version equals 101, and then the output directory, packages, and then I'll hit enter. Okay, and we have now our new NuGet package in this location. In the next lesson, we will update the identity microservice to publish events when the user GIL is updated. Let's now update our identity microservice to publish a new event anytime a user is updated. So here we are in the identity code base, and I'm going to go into our contracts directory, into our contracts.cs file, and here's where we're going to add our new event. So I'll just add a new line here, and I'll call it public record user updated. And this is going to have a user ID, an email, and finally the new total GIL. Okay, and again we use the word new total GIL just to make sure that it is clear that this is the complete total amount of GIL that this user has now regardless of how much was debited or credited in the previous operation. And now let's use this event, right? So let's go into our consumers directory, debit yield consumer, collapse this, and let's go down into the consume method. Just after we do the update async operation, where we have our publish call for yield debited, scrolling down, we're going to publish our new event. And we're going to do something similar to what we did in inventory, right? So we're going to say var yield debited task equals that one. And then we'll say var user updated task equals context.publish new user updated. And here we'll say user.id, user.email, and user.yield. And finally, we will say await task.when user updated task and yield debited task. So this way, just like in inventory, we can execute both times at the same time, right, in parallel, or actually let the runtime execute both tasks as parallel as possible. And after when all is complete, this consume method is complete. The next place where a user can be updated is in our register page, where we don't actually update a user, but actually register brand new ones, right? But for our purposes, it's really the same thing. So let's go into register. So let me do Ctrl+Shift+E to show my Explorer. And I'm going to go into areas, account, and register cs.html.cs. And let's collapse this. And the first thing we're going to need here is an instance of our iPublish endpoint, right? The mass transit iPublish endpoint that we can use to publish messages. So what I'm going to do is just go down here. After our last declaration of a field, private field, I'm going to declare private read-only iPublish endpoint, publish endpoint. And let's click here to do control dot, and let's import mass transit. And now let's do control dot in the variable declaration so that we can say add parameters to register model. This one here. And as you can see, that's going to go ahead and add the parameter, injects the publish endpoint here, and it assigns it to the variable that we just declared, which is super handy. And now what we're going to do is just scroll down into the section when we do on post async, this method here. And remember that this is the place where we create our user, right? So this is the exact line where we define the user variable, right? We assign the yield, and then we set username and email, and then finally we create the actual user in via the user manager into the users database. And then if that's succeeded, we have this message here, and we follow that with a call to a role async, right? To say that to assign the user to the payroll. So this is a good time to go ahead and also publish our message. So I'm going to introduce a line here that's going to say wait publish endpoint dot publish, and then this is going to receive our brand new, so we'll say new user updated. Okay, and let me do control dot here so that we can import play.identity.contracts. Okay, and here we're going to pass in our user.id, user.email, and user.yield. Okay, and we finish that line. So anytime from here on, anytime a user is registered into the site, and after it's created into the database and added to the role, we will also go ahead and publish this user updated event. And lastly, we should also update our users controller, where we provide support for updating users via our REST API, right? So let's once again Ctrl+Shift+E to go to our Explorer, and let's scroll down into controllers and users controller, and let me collapse this. And once again, we will have to declare our publish endpoint, right? So I'll do private read only iPublish endpoint, publish endpoint. I'll do control dot. We will say using mass transit, and then I'll do control dot here to add parameters to users controller. This one here. Okay, so publish endpoint is being injected, and now we want to go down into our put async method. And just after this update here, we're going to go ahead and publish our message. So we're going to say await publish endpoint.publish new user updated. And let's do again control dot here using play.identity.contracts. And we'll say user.id, user.email, and user.jill. And one more thing that we can actually do here is to also look at the delete async method. So this is when a user gets deleted, right? So what does that mean in terms of notifying our subscribers? What I think what we can do here is to just say that this user basically doesn't have any more Jill, right? Because the user doesn't exist. So what I'm going to do is just copy this line, the publish line that we just wrote. I'm going to go down into delete async, and just after deleting the user right here, I'm going to add one more line, and we're going to just say user updated, but the Jill is going to be 0 because, well, the user doesn't have any more Jill because he doesn't exist. Of course, you could come up with something more elaborate here if you wanted to notify other services that the user has actually been deleted. So you could add a new user deleted event if you wanted to, and then the other services can handle that event properly. But for now, this should be good enough for our purposes. Lastly, let's go ahead and publish our new NuGet with the updated event. So I'll do Ctrl J, and I'll go to my terminal. I'm going to remove this one, and then I'll go up one level, and then I'll go to play.identity.contracts. And here I'll do .NET -p package version equals, it's going to be 101, and then the output directory is going to be over here in packages. Hit enter. And now we have our new contracts, identity contracts package in this location. In the next lesson, we will update the trading microservice so it can consume the new events from inventory and identity. Let's now update our trading microservice to consume the new events published by inventory and identity. The first thing to do is going to be to go into our play.trading.service csproc, because we have to bump the version that we've been using from both inventory and identity contracts. As you see, we have those two lines right here. And since we created new packages, all we have to do is to bump this version to 101 and this other one also to 101. So with that, we will click on the restore button here so that the new dependencies can be restored into this trading project. And then let's close this and let's close that. Now, the point of consuming these new events is so that we can create our local mini document collections, right, in trading with the data from those events. But to do that, we also have to have corresponding entities that we can use to store our documents in MongoDB. So let's go into our entities directory. And here's where we need to create two new entities, one for inventory items and one for the identity application users. For the one from inventory, that's actually very, very similar to the one that we have in the inventory microservice. So I'm going to go into the inventory code base right here. And I'm going to go into entities. And I'm just going to copy the inventory item entity that we have there. Just copy that. Back into trading, I'm just going to paste that into entities. And here we're just going to use what makes sense. But of course, before doing that, let's make sure we have the correct namespace. It should not be play inventory service. It should be play.trading.service.entities. So here we will make use of ID, user ID, catalog item ID, and quantity. But in this case, we're not going to require either of these properties. So I'll just remove them. Okay, remember that you don't have to store everything that comes from the events. You just need to store what makes sense for this microservice. The next one that we need is the application user entity. So that one we're going to create here. It's going to be a very simple entity. So just right click on entities, new file, application user.cs, So it's going to be namespace play.trading.service.entities, public class application user. This has to implement the entity interface. I'll do control dot here. We will do using play.common. And then I'll do control dot again to implement the interface. Yep. The main thing that we require is a GUID, and we will let it do it via a simple getter and setter. And the next thing that we're going to need is the yield. So how much yield this user has. So we'll say public decimal yield, and again with a getter and setter, which I'm just going to copy from the top there. And with those two entities in place, it is time to create the consumers. So let's go into the consumers directory, and we're going to create a brand new consumer that we're going to call inventory item outdated consumer.cs. I'm going to copy the name of the class there. Let's collapse this, and let's now declare our namespace. It's going to be play.trading.service.consumers. Public class is going to be inventory item updated consumer. And this has to implement, of course, iConsumer of type inventory item updated. And so let's import control dot here to import mass transit, and also control dot here to import play.inventory.contracts. And then one more time in iConsumer so that we can do control dot and implement the interface. So in order to store the data from this event, we are going to need our repository, right? Our Mongo repository. So let's add that as a private field here. So private read-only iRepository of type inventory item repository. Okay, let's do control dot and let's use play.common. And then let's do control dot here too to use play.trading.service.entities. Let's also do control dot here so we can generate our constructor, this line here, right there. Now we have a constructor that's injecting the repository there. Let's go down into our consume method. And first thing to do is to capture the message. So I'll do var message is equals to context.message. And then we need to find the inventory item that has been updated. So we're going to just say var inventory item equals await repository.getAsync. Then we will say item should be the one where item.userID equals message.userID, and also item.catalog item ID should be the one in the message.catalog item ID. And yeah, I think we have one more parenthesis than needed. I'll just do this. And then let's make sure that this method is also an async method, right? So I'll do async here in the declaration. And then depending on if we find the item in our local collection of inventory items or not, we'll have to take some action, right? So we're going to say if inventory item is null, means that we had never heard of this item before. So we will just say inventory item equals new inventory item. And here we will say catalog item ID equals message that catalog item ID, user ID equals message that user ID, and quantity equals message new total quantity. And finally, we will just say await repository that create a sync with the inventory item. And then we go to the else branch, right? The else branch is when we are able to find the inventory item in our local database. So here we only have to say inventory item that quantity equals message that new total quantity. And then we'll just do await repository that update async and the inventory item. And that's all we have to do for this consumer. So anytime an inventory item is updated, we will either update it locally or we will create it locally. Now we have to do something similar for our user updated event. So let's do Ctrl+Shift+E and let's go to consumers. And once again, this time we're going to create, right click, new file. It's going to be user updated consumer.cs. Okay, let's collapse this. Okay, so it's going to be namespace play.trading.service.consumers, public class, user updated consumer, implements iConsumer of type user updated. And probably I'm going to bring the namespaces from our previous consumer to save a little bit of time. So I'll just grab all these namespaces over here, there. And then I'll do Ctrl dot in iConsumer so that we can implement the interface. And in this case, we're going to need, again, another repository, which is going to be private read-only iRepository of type application user repository. And before moving forward, we're missing one namespace here. For user updated, I'll just do Ctrl dot here. We're missing play.identity.contracts. Yeah, because we don't need play.inventory.contracts, which I'm going to remove here from the namespaces declaration. Okay, and then we also will need a constructor to do dependency injection. So I'm going to click on repository, Ctrl dot, generate constructor, user updated consumer. There. Okay, repository is getting injected. And now we can work in our consume logic. So just like before, we will say message equals context.message. And then we will try to find our user in the local database. So we'll say our user equals await repository.getAsync message.user ID. And of course, we need to make this method async. So I'll update that now. Public async task. And now we have to do something depending on if we find the user or not. So if user is null, we will just create a brand new one. So we'll say user equals new application user. And here we'll say the data ID is message.user ID. And the GIL is message.new total GIL. And finally, we will do await repository.create async with our user. Okay. But if we are able to find him, so we'll do else, we can find the user, then we will just do user.gil equals message.new total GIL. And then we will just do await repository.update async user. Okay, so that's all we have to do. So anytime user is updated in the identity microservice, we will either go ahead and create it locally, or we will go ahead and update it locally with the new total GIL. With that in place, we are mostly ready to use these consumers, but the last thing is to declare our new repositories in startup. So let's do Ctrl+Shift+E to go to startup, CS, collapse this. And let's actually go all the way up into our configure services method, where we are already declaring the Mongo repository for catalog items. And just after that, let's declare add Mongo repository for inventory item. And let's name this one, this collection is going to be inventory items. And just like that, let's add another one, Mongo repository, application user, and we will just name this one users. And so with all that in place, we're ready to start consuming those events from the other microservices. And to make sure that this is working properly, and before moving to the next thing, let's just execute one purchase across using Postman. And then after that purchase, our new inventory items and users collections should get populated, right? Because an inventory will be granted, inventory item will be granted, and a user will be updated. So let's start on microservices. I'll make sure I start first. I'll go to inventory. Let me go ahead and do cd play that inventory.service, and I'll do .NET run. And then I'll head into our identity microservice and we'll do the same thing. cd play that identity.service .NET run. And then let's head into our trading microservice. Here, I'll do the same thing, Ctrl J, terminal, and then we'll go into src, play that trading.service .NET run. With all those in place, I'll go into Postman and I'll go into the Post tab. And here I'm going to again purchase, once again, this is the ID for the antidote. So I'm going to ask, let's say this time we'll ask for 5 antidotes, right? And here's our idempotency ID automatically generated. And just make sure you have an updated access token in the authorization tab, which I already have one. And I'll just hit send. So let's just make sure that the transaction completed successfully. So I'm going to copy the idempotency ID. I'll go to our get tab and I'll update our ID with this new ID. I'll make sure I have my latest player 1 access token and I'll hit send. So the operation was completed. And then what we want to verify is that our new collections have been created for trading. So I'll go back to VS Code. Here's VS Code, here's trading. Now minimize this. I'll do Ctrl Shift P so that we can toggle the activity bar visibility. There. ... on the left side, MongoDB. And then here's where we can see our trading database. So I'll just right click on it and I'll do refresh. And as you can see, we now have our inventory items collection in trading with one document. Click on it, and this is going to be, so this is for our player 1 user. Here's the user ID, the catalog item that he just purchased, and how much quantity he has total of those antidotes. And the same way, we now have our users collection over here with one document. Let's click on it. And here it is, our player 1 user, which now has only 36 GIL. In the next lesson, we will create a new controller that will take advantage of these new database collections to provide data to the new store experience. The updated front-end portal you will explore in the next lesson includes a new store experience. And to support it, we need to add a new controller to our trading microservice. So before we can add this controller, first we need to introduce a couple of new DTOs. So let's head down into dtos.cs. And just after our purchase DTO, we're going to add a new DTO that we're going to call a store item DTO. This DTO represents each of the items that are going to be presented in the store view. So let's do public record store item DTO. Okay. And in this one, we're going to add an ID, a name, a description, a price, and one more property that we're going to call owned quantity. Okay, so the ID is the ID of the item in the catalog. Then we have the name and the description of the item, the price of the item, and how much quantity the current user owns of that item in their inventory. Then we're going to add another DTO that we're going to call public record store DTO, which will represent the model for the view that's going to be presented to the user. So this is going to include an IEnumerable of type store item DTO, the one that we just created, and we're going to name this property items. And let me do control dot right here to import system.collections.generic. And then it's going to also have decimal user GIL. Okay, so basically a store DTO is the DTO that we're going to send back into the store experience, the portal, and it's going to include all the items that the user owns at that point and how much GIL he has in his wallet. Okay, so with those in place, it's time to create our brand new controller. So we're going to go into our controllers directory. Let's right click on it and let's say new file. This one is going to be called store controller.cs. I'm going to copy the class name. I'm going to minimize this. And then let's do namespace play.trading.service.controllers. Then let's add our class, which is going to be public class store controller. And then as with every other controller, this has to inherit from controller base. And let's make sure we do control dot to import Microsoft ASP.NET Core.MVC. We need to make this an API controller. We need to define a base route for this controller. So let's define route. And this one we're going to call just store. And finally, we are going to need to know who is invoking this controller so that we can provide all the items and the GIL for the user. So we are going to require authorization here. So we're going to add the authorize attribute. So control dot, and let's import Microsoft.ASP.NET Core.authorization. And then this controller is going to need to interact with multiple repositories to do the job. So let's declare the first one. So it's going to be private read-only iRepository of type catalog item. And let's call this one catalog repository. Let's do control dot here in iRepository to import play.common. And then in catalog item control dot to import play.trading.service.entities. Okay, and then I'll copy this line a couple of times to add our other repositories. So the second one is going to be application user, and this is going to be our users repository. And the last one is going to be of inventory item, and this is going to be our inventory repository. Scroll down a bit. And what we want to do now is to make sure we inject all these three properties into the constructor. So I'll just do control dot in the catalog repository variable, and I'll say generate constructor store controller. So that creates a constructor right there with the catalog repository. And then I'll do the same thing. Actually, I'll move this constructor down. I put it down here. And let's do the same thing for user repository, control dot, add parameters to store controller, and then inventory repository, control dot, add parameters to store controller, right here. Okay, I'll send this to the next line so that we can see better. There. And with all those in place, we are ready to implement our get action. So I'm going to add a new line down here. So I'm going to scroll down, and let's call this one public async task of action result store DTO. Get async like this. I'll go into the task here to do control dot and use system.reading.tasks, and then into store DTO control dot to use play.trading.service.dtos. Let's also add the correct verb for this method. Right here as an attribute will be an HTTP GET. And then let's scroll down here. The first thing that we're going to need to do here is to figure out who is the current user, right? So that we can provide the items and the GIL for this user. So we can do that by doing string user ID equals user dot find first value, and then our well-known claim sub is the one that's going to be able to provide back that user identifier. Let's also click here, control dot, so that we import system.security.claims. Now, in order to provide this view of all the items for the current user, the first thing that we'll need to do is to get the list of all the catalog items. So let's do var catalog items equals await catalog repository dot get all async. Okay, so that gives us the entire list of items. The next thing that we need is the list of all the inventory items that this user currently has. So that we can do by doing var inventory items equals await inventory repository dot get all async. But in this case, we're going to pass an expression here that's going to say that I only want to retrieve the items where the item that user ID is going to be equals to the user ID that we just extracted from the subclaim. So we'll do GUID.parse, and then we'll pass the user ID. Okay, make sure we'll do control dot in GUID to import using system namespace, and then I'll close this over here, and that should do it. And the last thing that we want to have is the actual user so that we can figure out how much yield he has. So we'll do var user equals await users repository dot get async. Then we pass again GUID.parse user ID. Okay, so that gives us the baseline of the info that we need. And now it's time to construct this DTO that we're going to return. So to do that, we're going to do this. So var store DTO is going to be a new store DTO. Okay, let's do this. And this DTO needs two things: the list of catalog items, the list of items that the user has, and the current yield for the user. And we actually don't want to present just the catalog items that the user has. We want to present all the catalog items, but we want to include how much of each of them this user has, even if he has 0 at this point. So to do that, we're going to do a projection. So we're going to do catalog items dot select. Okay, and let's do control dot here to import system.link. And in this select, we are going to project catalog item. Okay, we project it. And from that one, we create a new store item DTO, which requires a few parameters, right? So we have to provide here catalog item .id, catalog item .name, catalog item .description, catalog item .price, and finally the owned quantity. So how are we going to figure out the owned quantity? Well, what we can do here is just do another projection from the inventory items collection. So here's what we can do. Inventory items dot first or default, where inventory item is inventory item dot catalog item ID equals the catalog item dot ID. Okay, so this expression here, first or default, will give us the very first inventory item that we can find in the inventory items collection, whose catalog item ID is the same catalog item as the one that we are iterating over right here, this one here. And so first or default can return either the item or it can return null. So we're going to use question mark here so that then we can read the quantity if there is one quantity, but if there is no quantity, we will just use the equal else operator to return 0. And then finally, we have to provide the other parameter to the store DTO, which is the amount of yield of the user. So here we can just say user dot yield, and if we may or may not be able to find this user in our local database. if for some reason we never receive an event that says that this user has performed some update. So just to take care of that, we're going to add a question mark here in case we don't find it. And then if we find it, we get the user.yield. And if we don't, we do call else operator, and then we say just 0. And I think I have one more parenthesis than needed here. So let me just remove this one, do this, and that should do it. Okay, so just to recap, what's happening here is that first we're getting the data of all the catalog items from the repository. Then we get all the inventory items for the current user that we find out via the subclaim. Then we get the user from the user repository. And then we build this store DTO, which is kind of the model to be presented to the view in the front end. So this model needs two things: the list of all the items in the catalog and the current yield for the user. For the list of all the items, we go ahead and say, okay, so read all the catalog items, right? So iterate over all the catalog items. And then for each one, construct a brand new DTO, what we call store item DTO, with all these details. And then the last item here is how much this user has of this current item. And to figure that out, we go ahead and query the inventory items collection. And we say, try to find the first one of these inventory items that matches the catalog item that we are iterating over right now. If we can find it, get the quantity. If you cannot find any, just return 0. And lastly, for the second parameter of the store DTO, we query the user.yield, how much yield he has. And if for any reason we are not able to find the user currently, because for any reason the user has not been synced back into our local database, then we just return 0. Okay, and then finally, we'll go ahead and return OK. So I'll just scroll down here. I'll do return OK of store DTO. Okay, so that's all we have to do to define this controller. And now we can try it out in Postman. So what I'm going to do is just to Ctrl J to open my terminal right here. I'll switch into src play.trading.service and I'll do .NET run. And I have already started my other microservices. So let's go to Postman. And here in Postman, what we want to do is to query our store controller. But let's do a couple of things before that. First, since now we have a full and completed set of REST APIs for the trading microservice, what we can do is to actually import the Swagger API document to generate the collection right here in Postman. So to do that, let's head into our browser. So I have a browser right here. I'm going to open a brand new tab and I'm going to go into HTTPS, localhost, and it's going to be 5007. So remember, that's the port that we have for the trading microservice, and then Swagger. So here's the Swagger UI page for the trading microservice. What we're interested in is actually in this swagger.json document here. So I'm just going to right click on this, copy link, and let's go into Postman. Then I'll do import link. I'll paste that link, and then I'll hit continue, and then I'll hit import. So now let's collapse these other two. Now we have our trading service APIs available here, so we can start exercising them. Let's also make sure that we update this base URL that we have here. That right now for trading service actually has nothing yet. So let's do ... here, and let's do edit. Okay, let's do this. Let's go into variables, and here we're going to put the location, the base URL for our service, which in this case is going to be HTTPS, again, HTTPS localhost 5007. And we'll do the same one for our current value. So I'll just copy this into this side, and that will do it. So I'll just click on save over here, and I'll close this. So now anytime we go ahead and query any of the APIs from trading, we'll have that new base URL available. And with that, let's go into our get store operation here, right there. And then as you can see, the base URL already has localhost 5007/store. And let's get an authorization token here. That's important. So authorization OAuth2, and I'll likely need to get a new access token. So let's click on manage tokens. Yeah, this one is expired. I'll just delete that and I'll head down into get new access token. I'll log in as player 1 because I want the inventory items for player 1. Okay, proceed. This is our player 1 token. Say use token. And with that, I'll just hit send. And as you can see down here, we have what will be the model for our new front-end experience. So this has, let's see if we can do this up. Yeah. So we have an items collection here that currently has all the items that we have in catalog, which are the high potion, the potion, and the antidote. Each of them with their ID, name, description, price, and own quantity. And lastly, we have the total amount of yield that the user has. Okay, and then just to confirm that this is working properly, let's go ahead and perform another purchase, right? So in this case, let's say we're going to go for a high potion. So I'll just copy this ID of the high potion, just copy that, and then I'll head to our familiar post operation for the purchase in the trading API. And then I'll copy that into the body. So I'll scroll down a bit. Let's put that into the body there. And let's say we're going to purchase 2 high potions. And then we have the Idempotency ID. Let's make sure we have the updated authorization access token. So I'll click here, player 1, back to body, and then I'll hit send. Here we have our Idempotency ID. Let's make sure that the operation completed already. So I'll just hit copy, back into our get tab for the status of the purchase. I'll delete this and paste the new Idempotency ID. I'll pick the correct access token, player 1, and then I'll hit send. And indeed, the operation has completed. But more importantly, let's now go back into our new API for the store and let's hit send. Let's see what we get now. As you can see, the own quantity for high potions has bumped into 2. So this is correctly reporting how much of each item our user currently has. Now, it may be that one or more of these items here does not have the current own quantity as reported by inventory, but that's just because the new trading, the new collections in trading may not have had the chance to get the event specifying that potions are already owned by this user. But that is okay, and that will get updated as you start creating transactions end to end in the portal. In the next lesson, we will finally use the updated front-end portal to query the new store API. It's time to explore the new store experience that is included as part of the updated front-end portal. You will find all the files for this new version of the front-end in the front-end zip file attached to this lesson. So, if you still have the old front-end files in your box, please delete them now and then download the zip file and extract it on the same location where you had the older files. In my case, I have already done that and I have my new front-end files in my play.frontend directory you can see here. So I'll open my VS Code instance in that directory. So I'll go into play frontend and then I'll do code dot and then -r to reuse the current window. Okay, so here we have the updated front-end portal files, and the first thing that we're going to do is to kick off the installation of the updated dependencies. So I'm going to do Ctrl-J here to open my terminal, and I'm going to run npm install. So this is going to bring in dozens of node models that are needed for this portal, and it's actually going to take a while. So while that happens, and you can just close this terminal while that happens, let's explore a little bit of what's new in this version of the portal. So I'm going to open the source directory here, and I'm going to go into app.js. And so a couple of things that are new in this file are the declaration of our new store model that we're going to look at in a second, right there. And then also, if you scroll down, there's also a new authorized route that points into that new store model in our store path. Now, if we go into components and then we go to home.js, we're going to notice that if you scroll down, there's going to be a new link in the home to go into the store right here. And then also we will offer the Swagger UI location for our new trading microservice right here. Then also, if you go to the navmenu.js file and you scroll down, you're going to find all the way down into authenticated view. So when a user is authenticated, regardless of if he is an admin or a player, there's going to be this new store and inventory items function that, if you scroll down a bit, is now going to include both my inventory link, but also the new store link. Now let's head into our new store file that's right here, so store.js. And this file is the one that is kind of our entry point to the whole store experience. So this is the one that shows that list of items and the amount of yield available to the user. So if you scroll down here, you're going to see that here is where we get an access token, and here's where we call the new store REST API that we created in previous lessons. And as we get it, we go ahead and populate the state of this component with what we get from that store API. And of course, also after we got that, we can render the view that you're going to be able to see much better in the portal in a few seconds. Now also, as part of this render view, you're going to see that we are including the purchase model. And this purchase model component is the one that will eventually take us into the purchase experience. So let's take a quick look by going into form and then purchase model. And here, what you're going to find is that in the render method, we have two things, which are the button that you're going to see in the list of items to click on purchase to purchase that item, and then the model dialog for presenting the purchase form that is right here. So let's take a quick look at purchase form also. And in this form, there are actually many things are going on. So we're not going to take a look at everything that's happening here, but mainly I want you to take a look at the following method, submit purchase. So this is where we will go ahead and say, okay, so we'll check the validity of all the input fields in the form. And if everything looks right, we will jump into purchase item. Let's scroll down into purchase item. So here is where, after confirming the purchase with the user, we will go ahead and actually generate our idempotency ID, right? So this is the point where we prepare this unique identifier for the entire purchase transaction. And when we have it, we will pass it into the fetch retry method, along with a number of retries, because we have to consider what happens if the operation fails and we need to retry it, right? So we go into fetch retry, and here is where we will get our access token. And then we invoke the purchase API by passing the item ID to purchase, how much quantity, and our idempotency ID. So it goes to trading microservice. And if, let's keep going down, if the trading microservice says, hey, I cannot complete this purchase for some reason, then we will land into this section here. But otherwise, if purchase trading says, yeah, everything succeeded, then we will say, okay, so purchase request completed with some status. However, if there is some sort of very unexpected error, like the kind of a network error, right? For some reason, we cannot get back a response from the trading microservice, then we land into this catch section here, this whole section, where we will do retries, right? And then we are keeping a counter here for how many retries we're going to do. And the first time we will not enter into this block, we will go all the way down here. And here's where we're going to say, okay, so after 5 seconds, we will go ahead and invoke again the fetch retry function. But notice that we keep using the same idempotency ID. So that's a key part. Keep using the same idempotency ID so that when we come back again into fetch retry all the way up here and we enter again, we keep using the same idempotency ID, and that's the one that we use to send a new request to the trading microservice, the purchase API. That's how we can make sure that there's no duplication in this transaction. Okay, so if you go down again, if eventually the retry, we keep trying, we try 3 times and we cannot get a successful response, then we will present an error message to the user, of course. But otherwise, hopefully, we will be able to land in a successful case. Okay, and another new thing that I can show you here is if we go into the public directory into config.js, you're going to see, scroll down a bit, that we have a few new URLs here, specifically these 3 ones here for the trading microservice, and the corresponding URLs for the purchase API and the store API. And then one last thing, if you go down into source components, API authorization, and then authorize service, and if we go into the ensure user manager initialized method, yeah, so let's find the definition of this method, which is right here. You're going to see that in the set of scopes that we're defining now, right? So in this line here, we are now including the trading.full access scope, which is the new scope that grants the client access to our trading microservice. And so one thing that we have to do before starting our portal is to make sure that the identity microservice is allowing this scope for our front-end portal. So let's do that change quickly right now. So let's go back into identity. Here's the identity microservice. Let's go into app settings.development.json, and let's go into the front end, client. You see, here's the client section. Here's the front end client within the identity server settings. And here's where we have the allowed scopes. So just after inventory.full access, let me add one more line here. And this is going to be trading.full access. So with that, our front-end client gets access to the trading microservice. So I'll do Ctrl J here, and then I'll do .NET Run to get our identity microservice started. Now, the other thing is that our trading microservice has not allowed the proper CORS configuration just yet, right? Because it never needed a client like the front end to talk to it. So let's also enable CORS in trading to make sure that the client can talk to it. So let me go back to, here's the trading microservice. And a couple of things to do here are, let's go into app settings.development.json, just like we did for the other microservices. And we're going to add a little section here that says allowed origin. And the origin again is going to be the location of our local portal. So that's HTTP localhost 3000. And with that in place, we can go into our startup file. And as we did before, let's define, just at the start of the startup class, let's define a variable, a constant actually for this string that we just created. So private const string allowed origin setting is going to be that setting that we just defined here. Let me copy the name, allowed origin, copy, and then I'll put it right here. Then we're going to go down into our configure method over here. And I'll collapse this. And inside the if m.isDevelopment section, because this is only for a development scenario for now, is where we're going to enable CORS. So just as we did before, we will do app.use CORS, and then we get our builder, open a lambda expression here, and then we will say builder with origins, and then we will get that from configuration, our allowed origin setting. Okay, so that allows our front-end portal to use CORS against our trading microservice. But then we also have to allow any header, and then also allow any method. That's all we need for now. And now we can do, let me do Ctrl J. I'll go to my terminal. I'll kill this terminal there. And then I'll just do .NET Run. So with that, we're actually ready to start our portal now. So let me also make sure that our other microservices are up and running. So I have catalog here. I'll do Ctrl J, and then I'll do .NET Run. And I also have my inventory microservice over here, for which I'll do .NET Run. Now going back to our front-end portal, here we are. just close this for now, and then I'll do Ctrl J, and then I'll just do, as you can see, all the dependencies have been installed by now, and then I'll do npm start to start our Node.js server. All right, so now we can go into localhost 3000 to see our portal. So I'll just Control click there, and that opens my browser right here. And so as you can see, we have a link to the store right here, and a link to the trading service now over here. So now let's go ahead and log in as player one, play.com. Okay, so logged in. And as you can see, we have our new store menu item right here at the top. So I'm going to click on it. And here's where you can see the view that corresponds to that store API that we created before, right? So now it's just looking much better. So in this view, you can see all the catalog items available and presented by the catalog microservice with their names, descriptions, and prices, but also thanks to the data from the inventory microservice, we can tell how much of each of these items is owned by our player one user right now. So he will have 2 high potions, 1 potion, and 90 antidotes. And you can also see how much gil the user has available right now. And then this might look different for you right now. So what I did actually beforehand is I went into the users section as an admin, and I made sure that the user has 100 gil here. You can update that easily over there, because otherwise we may not have enough gil to perform a purchase here. And so with that in place, let's say that we want to purchase a potion. So then you will go ahead and click on purchase. And then here's where you can see the price of the potion already. It's grayed out. And then the quantities, how much of this we want to purchase. So let's say we want to purchase 2 potions. And then you click on purchase. There's going to be a confirmation. And then you click OK. So as you can see, we get some progress here. And that will go ahead and turn into an actual purchase button back again and give us some status back when the purchase operation is completed. However, there is still a missing part in our trading microservice that is preventing that from happening. And we're going to take a look at that in the next lesson. But for now, if you just close this, and then you refresh this page, you will see that the purchase operation has actually completed because the user now has 3 potions and the yield has been deducted from his balance. So really the purchase operation was a success and the entire state machine operated as expected. It is just that the experience is not complete, and this is because the portal is expecting the trading microservice to report back into the front end when the entire purchase transaction has completed. So how can trading notify back of purchase completion into the front end? So in the next lesson, we will learn about SignalR and how it can provide real-time updates into our front end. In this lesson, you will learn how SignalR can be used to provide real-time updates to your front-end users as they go through the purchase experience. As you know by now, when the user clicks on the purchase button, he will arrive at this purchase model dialog. As you can expect, clicking in the purchase button here will send a post request to the purchase endpoint of the trading microservice REST API, to which trading will immediately reply with an accepted response. The purchase process can take some time, since it involves a state machine and the participation of 2 other microservices. Therefore, the purchase dialog will transition to an in-progress state, giving the backend time to complete the operation. Now, how can the frontend know when the purchase operation completed? One way is of course by sending a GET request to the purchase status endpoint, which will receive an idempotency ID and will return the status of the purchase. However, depending on how long the process takes, the frontend might need to poll the service for status multiple times until it eventually gets a completed status. This certainly works, but the problem is that as you scale your system, there could be dozens or hundreds of users trying to perform a purchase from the frontend, which translates into an increasing number of GET requests to the trading microservice to ask for status. You can of course scale your service to handle the increasing amount of load, but this is a bit of a waste of resources, plus the front end will likely introduce a delay between each GET request, which could result in the user to keep waiting when the operation might have already completed. There is a better way to do this, and here is where SignalR comes into place. SignalR is an open source library, part of ASP.NET Core, that adds real-time web functionality to apps. This enables server-side code to push content to clients instantly. What this means for our system here is that instead of having the front end constantly poll the service for updates, we will now have a hub that both the front end and the service can use to send messages to each other. This hub will be available through the entire lifetime of the purchase dialog. And now, as soon as the purchase state machine completes, trading can send a real-time message to the client, notifying it about the purchase completion, or of any failures in the purchase process if that would be the case. That way, we save precious service-side resources, and we don't keep our users waiting to receive updates for more time than needed. In the next lesson, you will add SignalR to the trading microservice to complete this purchase experience. When using any of the protocols supported by SignalR, like WebSockets, the access tokens presented by the client will not be read by the authentication middleware by default, which will cause authentication issues between client and server. Let's fix this by updating our authentication configuration logic in our common library. So here I am back in our common codebase, and if you remember, if you go into identity and into extensions.cs, you remember that this is the method that we are using to add the JWT better authentication into all of our microservices. Now, the way that we configure this is via the configure JWT better options class that we have defined over here. And let me collapse this. So this is the class that we're going to have to modify to make sure that the access tokens are also available when using WebSockets or any of the other SignalR protocols. So to do this, first thing we're going to do is define a couple of constants here at the top. Let's define private const. It's going to be a string, and let's name it access token parameter, which is going to be just access token. And this is going to be the name of the parameter in the query string that we have to get access to retrieve that access token from the request to use it later. Then we're also going to define private const string message hop path, and then the value of this is going to be /message hop. And this here is going to be the path where the client can access the message hop or the SignalR hop that we will be enabling in our trading microservice in the next lesson. So for now, let's just name it a message hop, and you'll see how we use this in the next lesson. And now that we have that, we can actually do the configuration. So let's scroll down into the configure method. And just after this last options configuration, let's open up another section. Scroll down here. And we're going to define options.events equals new JWT better events. And here, what we have to define is a handler for the onMessageReceived event. So we can do that by saying onMessageReceived equals, and then we're going to receive a context. Okay. And then here we have to define what to do when a message is received, in this case from a SignalR communication. So first thing to do is to retrieve that access token. So we're going to say access token equals context that request, which is the request context, and then from the query we're going to retrieve the access token from using the access token parameter. And the next thing that we're going to need is the path, the current path that has been requested on the server. And to do that, we're going to do just var path equals context.http context request that path. We need to know this because we only want to execute this logic here to transfer the token from one place to the other when the client has requested the SignalR hop path. So not for any other path in our microservice, but only for the hop path. So let's see how to do that. We're going to say that if not string that is null or empty access token. So if we are able to actually retrieve that access token, and also let's go to the next line. If the path here starts with segments, and this is going to be our message hop path that we just define as a constant, then we know that we are in the right place. So let's open up this. And here is where we're going to do the transfer of that access token into the request context. So we're going to say context, that token equals access token. And finally, we're going to do return task dot, let's do control dot here. And let's do using system that read the tasks, task dot completed task. Because this is going to be, that's what it's expecting to receive a task. So it has to make sure that we also return a task. So let's close column there, and that should do it. So just to recap, what we're doing here is to configuring our authentication logic, our JWT bearer authentication logic, so that anytime a message is received for authentication, and if we retrieve the access token from the request query string, we figure out what's the path, and if that path is the message hop path, like / message hop in this case, and only in that case, we will go ahead and take that access token that we retrieve from the query string and copy it into this message received context that Signaler is going to use. Okay, so that's already for this class. And then what we need to do is, of course, produce a new NuGet package that our trading microservice can consume later. So I'll do Ctrl J, and I'll go into src, make that common, and then I'll do .NET pack -p package version is going to be, in this case, is going to be 105. And as usual, we will send the output into our packages directory right there. Hit enter. Okay, and our new NuGet package is ready to go. In the next lesson, you will use this new NuGet package and the Signaler APIs to enable real-time notifications in the purchase experience. In this lesson, we will learn about the .NET Secret Manager and how you can use it to safely store secrets during your microservices local development. As you know, so far we have been trying to keep all configuration-related data outside of our C# files and into the app-settings.json and app-settings.development.json files. And we are doing this because we know that these files are just two of the possible .NET configuration sources that can easily be replaced at runtime, without touching the codebase, depending on the environment where our microservice is running. Soon, our identity microservice will need to provision an admin user as part of a service boot sequence. And in order to create that user, it's going to need some configurable details like the admin user email, which we will certainly store in the app-settings.json file. And as you may guess, alongside that email, we are also going to need a password to properly identify this user. We could go ahead and also add this password to our app-settings.json file, but that is not quite a good idea. This is because eventually you will likely push all your microservice code, including app-settings.json, into some repository in a source control system like Git. If that repository is public, you will be exposing the password to the world. And even if it is private, there is always a chance that the source control system gets compromised and your passwords can leak. Luckily, there is another kind of configuration source that you can use for storing secrets, at least for local development. And that is the user secrets configuration source, which stores its contents in a file called secrets.json. This file is completely separate from your codebase. In fact, it lives in your local machine user profile. You could add values manually here, but you don't have to. In fact, you don't even need to know where this file lives, because there's a built-in .NET tool designed to deal with this file, the .NET Secret Manager. You can use a secret manager to create, update, or remove secrets in this file, while at the same time getting the secrets associated to your microservice projects. So we will use the secret manager to create and store our admin password, and ASP.NET Core will take care of loading it along with the admin email from app.settings.json during our microservice boot sequence. After which it will also merge the values from both configuration sources into the configuration object we have been using in our startup class. From our microservice code point of view, the data just shows up in the configuration object, so it doesn't need to know where the different values came from, which is a very powerful concept. We can then introduce a proper class to represent these admin user settings, which we will call identity settings. And just as we have done before, we will read and deserialize the values from configuration into identity settings in our startup configure services method. Then, later in the boot sequence, we will use identity settings to create the admin user via the ASP.NET Core Identity User Manager object. So, by using the .NET Secret Manager, we are making sure that the microservice secrets remain outside of source code, which will prevent them from making their way into our source control system. We don't make our code base any more complicated, since the microservice code doesn't need to know where the secrets really live, and ASP.NET Core loads the user secrets configuration source by default. But also keep in mind that the secret manager is only meant for local development scenarios. So don't expect the secrets you put in there will be available to the microservice once you deploy it outside of your dev box. Also, don't place production level secrets in Secret Manager, since the data is stored in plain text in the secrets.json file. In the next lesson, you will learn about the need for authorization checks in your microservices and the different ways ASP.NET Core allows you to perform authorization.